Good day everyone, I am Sose Momesa and I am going to discuss you about the consolidated drain triaxial. In triaxial shear stress, test is a common method to measure the mechanical properties of many deformable solids, especially soil, and rock and other granular materials or powders. There are several types of triaxial tests. We have consolidated drain triaxial, consolidated undrained triaxial, unconsolidated undrained triaxial, and the true triaxial test. In consolidated drain or CD test, the sample is consolidated and the shear is compression slowly to allow pore pressure built up by the shearing to dissipate. The rate of actual deformation is kept constant, strain is controlled. The idea is that the test allows the samples and the pore pressure to fully consolidate to the surrounding stresses. The test may take a long time to allow the sample to adjust. In particular, low permeability sample needs a long time to drain and adjust strain to stress levels. In consolidated drain, run in such a manner so as to cause no change in neutral stress. Any increase in total stress produces a corresponding change in effective stress. The consolidation of the soil takes place in two stages. First, the soil is consolidated under the confining cell pressure, and the second during the application of the axial load. In both stages, the soil is allowed to drain freely, and the stresses are applied slowly so that the neutral stress remain unchanged. The void ratio and the water content are reduced during both stages. In stage 1, we apply all-around pressure, sigma 3. Drainage is often allowing dissipation of excess pore pressure, which means UC is equal to 0. Thus, consolidation. The change in volume determines the volume of water drain. In stage 2, we apply deviator stress very slowly. Drainage is often, which means delta UD is equal to 0. Those drain condition. So we have the figure about a consolidated drain triaxial test. On the left side, we had specimen under the chamber confining pressure. In the right side, we had the deviator stress application. Because the pore water pressure developed during the test is completely dissipated, we have total and effective confining stress. Sigma 3 is equal to sigma 3 prime. The total and effective axial stress at failure is equal to sigma 1 is equal to sigma 1 prime. In triaxial test, sigma 1 is the major principal effective stress at failure and sigma 3 prime is the minor principal effective stress at failure. So we have this figure, the effective stress failure envelope from drain test on sand and normally consolidated clay. Also, the failure plane will be inclined at the angle of 45 plus 5 prime over 2 to the major principal plane as shown in figure 12.22. So, we have now the angle of internal friction is equal to the sine inverse times sigma 1 prime minus sigma 3 prime over sigma 1 plus sigma 3 prime. Overconsolidation results when a clay initially is consolidated under an all-around chamber pressure and is allowed to swell by reducing the chamber pressure to sigma 3 is equal to sigma 3 prime. The failure envelope obtained from drain triaxial test of such overconsolidated clay specimens shows two distinct branches AB and BC in figure 12.23 sa baba figure. The portion AB has the flattered slope with a cohesion intercept, and the shear strength equation for this branch can be written as that the shear stress is equal to C prime plus sigma prime tangent pi prime 1. The portion BC of the failure envelope represent a normally consolidated stage of soil and follows the equation. A shear stress is equal to a sigma prime tangent pi prime. If the triaxial test result of two overconsolidated soil specimens are known, the magnitude of the pi prime 1 and the C prime can be determined as follows, or the angle of internal friction, and the cohesion of soil. For specimen 1, we have this formula 12.21, and for specimen 2, we have formula at the bottom. Hence, the angle of internal friction is equal to 2 times tan inverse times sigma 1 prime 1 minus sigma 1 prime 2 over sigma 3 prime 1 minus sigma 3 prime 2 to the power of 0.5 minus 45 degrees. Once the value of the internal friction is known, we can now obtain the cohesion of soil by using the formula in 12.24. A consolidated drain triaxial test on a clayey soil may take several days to complete. This amount of time is required because the deviator stress must be applied very slowly to ensure full drainage from the soil specimen. For this reason, this type of triaxial test or CD type is very uncommon. So that's for the introduction of the CD triaxial test. And to further understand the formula and the equation, my group mates will have several examples about this report. So thank you and have a good day.